Welcome to my introductory video of how to find a network ID in relation to having a subnet mask. This is the idiot-proof method of doing this. Follow and solve in this order. 1. The network ID. 2. First host ID. 3. The next network ID. 4. The broadcast ID. And lastly, the last host ID. We start by learning bit values. 128, 64, 32, 16, 8, 4, 2, 1. And you can think of these also as 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and so on and so forth. You will need to know that for later problems. Anyway, think of each of these numbers as numbers on a lotto ticket. For each number that gets a 1 in binary is money that you win. This ticket allows you to win 30 times. So, what you're going to do is write out these ones 30 times because that is our subnet. So, first octet, meaning 8, is all ones, all ones, all ones, 8, 16, 32, and up until we hit 30. If you notice, the 30 lands on the 4 in our bit value. In case you can't do math, which I certainly hope you can, this will be our magic number that we will determine the first thing, our network ID. That 4 tells us our network is on multiples of 4. I'm going to zoom in for you so you can read my little text box. And it basically reiterates what I just said, but I'll read it again. 4 is our magic number. Our network ID will be determined by reaching 161 and multiples of 4. You need to start at 0. 0, 4, 8, 12, etc., blah blah blah, until you hit 160, 164, and 168. There's no point to go past 168. The network ID is always the lowest number between the multiples. Excuse me. Example, 156 precedes 160. 164 is after 160. Our network IP address in our last octet, 161, tells us our IP address up here, 217.43, 144, 161, and blah 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 blah, where am I? Oh yeah. The lowest number in between these two, 160 and 164, is going to be 160. And bam! We learn our last octet, which is our network ID number, is 217, 43, 144, 160. Ignore that last part because it doesn't matter. It's onto another more difficult section. So, we know our network ID, and if you can't do math, well, life sucks. But for those people that are continuing and can do math, hell, even if you can't, I'll explain this to you. The first host is the next number immediately after our network ID. Guess what? 161 plus 1, 160 plus 1 is 161. It's been a long day. Don't judge me. Knowing that, take 160 plus our magic number 4, and that will give us our next network ID. And it'll also tell us everything else. Our next network ID, 164. The broadcast, which is always 1 less than the next network, is 163. Going by that logic, if our broadcast is an ID that we cannot use, and the first host is 161, what number lies in between those two? I'll give you a hint. If you're picking anything aside from 162, turn off the video now and go learn, I don't know, plumbing or something that doesn't require math, because you will probably fail. 162 is our last host. As a little bonus, I will show you a happy little table that I've devised to help you out in future problems. I call this my magic table. It gives us, again, the bit values right here. This is the dot notation value. For instance, let's say you see a subnet mask that says 255, 255, 255.192. Well, that 192 corresponds to having this 4 network and having 64 hosts. But keep in mind, you will be subtracting 2 from these numbers because of that broadcast and network ID number. These are the classes and subnet values, which also correspond to the dot notation numbers. For example, a class A /8 is a dot notation 128. A class C /32 corresponds to a dot 55. And these are our ranges from class A, class B, class C. Let's see if you're smart enough to catch the mistake I made. I'll stop the video there, and I'm not going to tell you the answer, but I hope you figured it out. Anyway, thank you for watching, and best of luck with the test, and if you can't do math, your life.